Hello, welcome back. We are starting chapter 2 today. So we're going to be doing conditional statements today, section 1. Now, before I get started, there are a couple things I want to tell you about chapter 2. First of all, every year people tell me this is the hardest chapter. So with that being said, you've got to come every single day on Canvas, get prepared, watch the videos, or else you're really, really going to struggle with this chapter. And even when you're watching the videos, you still might struggle. So please, please, please feel free to reach out. Let me know, hey, I'm really confused on this exact thing here. Can you help me with that? Now, don't email me and say, I'm confused. I don't know what I'm doing, right? But tell me, hey, section 1, especially this third example here, I really didn't understand what you meant. Can you elaborate or something like that? So please keep in touch with me if you're struggling. Second thing I want to tell you is most of chapter 2 is what's called logic in math, which it has a lot of words. I don't want to say they're word problems, but there's a lot of explanation involved in this chapter. And so if you don't want to have to write all of the stuff that's on my notes, I mean, it's long. It is a long list of crap that we're going to be talking about today. I would highly encourage you to print the notes. Now, I am going to send a text out Sunday night. So if you're watching this after Sunday, you already got the text. But I texted everyone Sunday night and just said, hey, print the notes for this week because they are very long notes. And there are a lot of things that are already in the lesson that you won't have to write down if you'll print them ahead of time. So if you have not printed these notes, you might as well just stop the video right now, go print, and come back because there is a lot of writing. By the way, if you have not gotten on my remind, I highly suggest you do that as well. You're going to text at G, I'm a tree. So you're going to text this to 81010. That'll get you signed up for my remind. I do send out little tips and hints, probably about at least once a week, but maybe even more often than that. Sometimes I'll also send you a picture of like the answers to the test review or something like that. So get on there if you're not already, okay, because it's really going to help you out in the long run. All right, let's go ahead and get started on today's lesson. So we're doing RL 1.2. We've been doing RL 1.1 for a really long time. We're on 1.2 now, which is to analyze and draw conclusions based on a set of conditions using inductive and deductive reasoning, which we'll get to another day. Recognize the logical relationships between conditional statements. And then we're also going to talk about inverse, converse, and contrapositive today. So those are kind of our goals for the day. We're also going to hit perpendicular lines a little bit later on in the section. Okay, so first definition is a conditional statement. A conditional statement is a logical statement that has two parts, a hypothesis and a conclusion. So a conditional statement is an if-then statement. So if this happens, then this will happen. So for example, if it's raining outside, then I will wear my rain jacket. That's a conditional statement. It has an if, which is the hypothesis part, and it has a conclusion, which is the then part. So many times a conditional statement will be written as an if-then form. The if part contains the hypothesis, the then part contains the conclusion, like I just said. The notation is if P, then Q, and it's written as P and then an arrow Q. So if P, then Q is like, if it's raining outside, then I will wear my rain jacket. The if P would represent if it's raining outside. And then the Q would be, I'm wearing my rain jacket. So here's another example. Oh, okay, apparently I like to talk about the rain. So the hypothesis is the first part. So if it is raining, comma, then, and then the conclusion is there are clouds in the sky. Now notice the hypothesis and the conclusion do not include the words if and then. The if then is always there. The other part, the hypothesis and the conclusion, are not the words if then, they're the other pieces, okay? So we can also, oh, I think I went too far. Here we go. Here's an example. So we're going to rewrite this statement right here in if-then form. So all birds have feathers. That's actually not even true, is it? Okay. So if it's a bird, then it has feathers. So we're going to take a normal sentence and turn it into a conditional sentence, which is if then. All right, let's try another one. All 30-degree angles are acute angles. So we're going to change it to if then, not all. So if it's a 30-degree angle, then it's acute. Okay, so we take a normal sentence, we change it into if this, then that. All right, now you can do what's called a negation, which is the opposite of the original statement. Now, when I say opposite, basically it's going to have the word not in it. So it says to write a negation of a statement, P, you would write the symbol negation, so it's a little squiggly line, before the P. So not P is written as squiggly and then a P. So that's just like the notation. So we're going to practice with these. So it says the ball is red. So get this, the negation of this, the ball is not red. It's that easy, right? The cat is, okay, now it already is not black. And so if it is not black, so you don't want to say it's white, you want to say the cat is black. I just wrote the wrong thing. Okay, the cat is black. Perfect. So you don't want to ever say not, because of course a double negation makes a positive, just like in math. Two negatives make a positive. Okay, next we're going to talk about the converse. So this was a negation when you add the word not, and then the converse of a conditional statement. So remember, conditional is the if then. The converse of that is when you exchange the hypothesis and conclusion. So normally the hypothesis comes first, it's P, then Q, right? That's normally how it is. But a converse is when you take the P and the Q and you switch them around. So the converse would be if Q, then P. So it would flip around, okay? So next we're gonna talk about inverse. The inverse is when you negate the hypothesis and the conclusion. So if not P, then not Q. And we're going to put sentences to this here in a second, so don't panic. Then we have the contrapositive. The contrapositive is a combination of the converse and the inverse. So if not Q, then not P. So you're going to flip it and you're going to put not. Okay, let's look at an example. So here's the original, here's the conditional statement. If it snows, then they cancel school. If it snows, then they cancel school. So this is like the P right here, and this is the Q, right? Then we have the converse of that. So that's the Q, then P. That's the one where we flip it, okay? So it would just simply be if they cancel school, then it snows. So you just switch them around. Next, we have the inverse, which does not switch them, but it negates them. So if it does not snow, then they do not cancel school. And then you guys know the contrapositive is going to be combining these two ideas here. So we're going to flip it around and we're going to negate it. So we have, if they do not cancel school, then it does not snow. All right, so that was an example to give you an idea of what they look like. Now we are going to actually practice writing these statements out. So it says, write the converse, write the inverse, and write the contrapositive of the following conditional statement. Then it's also going to ask you a follow-up question. Decide if those statements are true or false. So let's do it. It says, if you are a guitar player, then you are a musician. So first thing we're going to do is do the converse. Remember, that's the switch it around. So if you are a musician, then you are a guitar player. All right. Next, we're going to do the inverse. Remember, the inverse is not where you switch them around, but it's when you keep them the same way, but you negate both. So if you are not a guitar player, then you are not a musician. Okay, and then the last one, that's when we combine both of these. We take the inverse and the converse and we combine the ideas. So if you are not a musician, then you are not a guitar player. All right. So I showed you one, then we worked on one here together. Now I want you to do one on your own. So if you will please pause the video, I would like for you to fill this one in on your own. I even made it Call of Duty because hello, everyone loves Call of Duty, right? But what I want you to do for real, pause the video, fill those out, and then hit play and I'll have the answers there for you. Okay, so here are the answers. The Converse says, if I do not get any sleep, the new Call of Duty comes out. Now, you'll see that I use if I do not, and originally it says if I won't. If you change words like I will or I won't, like if you change I will or I won't to I do and I don't, that kind of thing isn't a big deal. So you want the sentence to make sense. You don't want to say if I will not get any sleep, right? You would say if I don't get any sleep. So you can kind of change those words around. It's not a big deal, but you don't want to leave off the not. Okay, so if I do not get any sleep, the new Call of Duty comes out. The inverse is when you keep them the same way, but you negate both. So you say not. So if the new Call of Duty does not come out, then I will get sleep, right? Because it said you wouldn't originally. All right, and then lastly, when you combine the two ideas, if I do get some sleep, then the new Call of Duty does not come out. Okay, I hope you did well on those. Real fast, I realized this while I was paused here. The previous slide, we forgot to see if it was true or false. So let's do that real quickly. I'll just use the highlighter. How about that? All right, on the first one, if you are a musician, then you are a guitar player. True or false? False. You can be a musician and not a guitar player, right? If you are not a guitar player, then you are not a musician. Also false, right? Lastly, if you are not a musician, then you are not a guitar player. I think that's true, right? If you are not a musician, so I can't play music, I can't sing, I can't do anything, then I can't be a guitar player. Yeah, I'm going to say that is true. So on the quiz coming up here in a few days, it's going to ask you some true and false questions like this. So make sure you're actually thinking about it logically on these. All right, next page. Like I said earlier, we're going to talk about some perpendicular lines. The definition of perpendicular is when two lines are crossing and they form a right angle. So you can see in this picture, we have some perpendicular lines. Now, did you notice that this is a conditional statement? If two lines intersect to form a right angle, then they are perpendicular lines. So there's that. But you needed to know that because we're going to talk about perpendicular here in a second. Remember that 90 degrees can also be symbolized with that little box there in the corner. So just a reminder on that. All right, so using the definition we just talked about, decide whether each statement about the diagram is true. Explain your answer using the definitions that we just learned. So part A says line AC is perpendicular to line BD. By the way, this symbol right here means perpendicular, the little upside down T. So it says line AC is perpendicular to line BD. True or false? Oh, goodness. That is true. And how do I know that? Because it has the right angle. So you would say because of the right angle. What else? Next, angle AEB. AE, let's say B. So this guy over here. And angle CEB, CEB, form a linear pair. How do I know? Yes or no? Okay, linear pair. Linear pair is when I have a line and I have another, like a ray coming off of it, forming a straight line with two angles only. I would say yes, those do form a linear pair. So I'm going to say that is true. And I'm going to say true, and then you would write an explanation here. My goodness, I can't write. You would write an explanation saying that a linear pair is when you have two angles that are adjacent, where they're touching, that form two opposite rays. So that was the actual technical definition of a linear pair, is that they are adjacent. Remember, that means they're touching, and then they are opposite rays for the other lines. Okay, and then we have ray EA, so EA, and ray EB. are opposite rays. I would say false, right? And your reasoning there that you would write down is because they don't point in opposite directions, right? They do not lie on the same line, and so they cannot be opposite rays. All right, 2 more slides, then we're done. I know it's a long one today. Okay, biconditional. Biconditional is when you have a conditional statement, so the if then, and its converse is also true. Okay, so let's think about that for a second. My very first one I told you guys was if it's raining, then I wear my rain jacket. Is the opposite of that true? If I wear my rain jacket, then it's raining. That's not true, right? So the statement that I just gave you is not biconditional because if I flip it, it's not also true. So biconditional is when the original and the converse are both true, okay? And it's going to have the words if and only if in it. So it would say something, a statement, if and only if, and then another statement, okay? Also, my hands are purple. Did you guys see that? I used purple shampoo this morning. That's why. Okay, so I'm sure some of you don't even know what that is. Okay, so the notation is going to be P if and only if Q, and it looks like, let me change my color here. It looks like this. So it's got a double arrow because that tells you it's true both directions. If you say if P then Q, it's true, and if Q then P, it's also true. Okay, so let's look at a couple examples here. So we're going to write a biconditional statement. So the first one says, if 2 lines intersect to form a right angle, then they are perpendicular. Now, let's talk about what the converse of that would be. If they are perpendicular, then the 2 lines form a right angle. Is that also true? Yeah, of course. If they're perpendicular, they form a right angle. If they have a right angle, then they're perpendicular, right? It works both ways. So that's what we would call a biconditional statement, and we're going to rewrite it with the words if and only if. So 2 lines intersect to form a right angle. Oops. And then in between there, like where the comma was originally, you would say if and only if they are perpendicular. All right, next one. If an angle is a right angle, then its measure is 90 degrees. Okay, flip that around. Is it true? If the measure is 90 degrees, then an angle is a right angle. Yeah, that's true. Okay, so we're going to write it as a biconditional. An angle is a right angle if and only if its measure is 90 degrees. So some things I want to point out to you here. Notice that the words if then are taken out, and where the comma was is where we insert the if and only if part. So I got rid of this word here and this word here. And in where the comma was right here is where I put the if and only if part. Okay, so a lot of people, when they write their biconditional statement, they say if an angle is a right angle, if and only if its measure is 90 degrees. So they say the if at the beginning and then they put it also in the middle, which sounds really weird, right? So make sure you take out the word if and you just start with an angle is a right angle, and then where the comma is, we insert if and only if, and then we take out the word then. Okay, so make sure you take out if then, and in the middle of it, you're going to put if and only if. One more slide. We're almost there. I'm so sorry. I know it's a long one today. All right, state whether the following are true or false. If it's false, explain why. And then the first example says, if the measure of angle A is 85 degrees, then the measure of its complement is 5 degrees. True or false? Now, complement, you might have to go back in your notes and check. Complement means 90 degrees total, and so this is true. 85 and 5 is 90 degrees. All right, next one. The measure of angle ABC is 90 degrees. True or false? A, B, C, A, B, C. So this angle right here. Yes, it is. How do we know? Because of the little right angle in the middle. All right, last one. Really, the last one. Whew, we're almost there. It says line PQ. Oh my goodness. And line ST are perpendicular. Ooh, this is a tricky one. Okay, says they're perpendicular. Is that true or false? Do they look perpendicular? They do, don't they? It's false. Here's why. Does it say it's 90 degrees? Like, does it say 90 degrees? Or does it have a little right angle there? Nope. So remember, in geometry, we cannot make any assumptions about what we see. It might look like it's 90, but couldn't it be 89, right? Couldn't it be 91? It could be really close to 90, but we don't know that it's 90. So I'm going to say false because we don't know if line PQ and line ST intersect at a right angle. Now they might, but we don't know that. Okay, so we have to say false. All right, you made it. You can pause me right now if you're sick of this, but to go over what we were supposed to go over here, conditional statement, covered that. Inverse, converse, contrapositive, covered that. This is the assignment that goes along with this section. Make sure you check Canvas so that you know when this is actually due, okay? Sorry it was a long one, guys. You can always rewatch, hit pause, fast forward, whatever you need to do to get caught up. Please, please, please start printing off the notes for this chapter. You saw how long it was. I'm sure you didn't want to write down all of this stuff on this screen, for example. So please print them out. I know it's a lot of stuff up front, so print them out ahead of time. That way we don't have to spend so much time writing. All right, guys, have a great day. I'll see you soon.